Everyone, this is Jeon Poljong. Today we will study NETCONF Based Network Management. NETCONF is specified by RFC 6241. You can click this link. You can access NETCONF. Okay, RFC. Introduction to NETCONF. In comparing network devices, most network engineers are familiar with the CLI. CLI stands for Command Line Interface. But for automation, CLI is not the best option. For creating a robust software automation, there is a requirement for strict data structures. That is, CLI can provide only strings of data without any structure. The NETCONF protocol solves this problem by allowing network devices to be managed by using software applications. NETCONF, this one is Network Configuration Protocol, provides network administrators with mechanisms to install, manipulate, and delete the configuration of network devices. Secondly, NETCONF uses an extensible markup language, that is XML-based data encoding for configuration data as well as protocol messages. NETCONF operations are realized on top of a simple remote procedure called RPC layer. The NETCONF protocol allows a network device to support a full formal application programming interface, that is API. Applications can use this straightforward API to send and receive full or partial configuration data sets. NETCONF allows the functionality of the management protocol to closely mirror the native functionality of the device. Lastly, NETCONF allows a client to use a set of protocol extensions supported by a server. So we can looking at one by one. So NETCONF RFC. A client encodes an RFC remote procedure call in XML and sends it to a server, NETCONF server, running a secure connection-oriented session like SSH or TLS over TCP. The server responds with a reply encoded in XML. The content of both the request and the response are fully described in XML. DTD stands for document type definitions. So we'll see the example DTD next slide, or XML scheme. Also we can see. So actual instance of DTD definitions. Okay, the purpose of DTD is to define the structure of an XML document. The XML DTDs and XML schemas allow both parties to recognize the syntax constraints imposed on the exchange. So we can see DTD and XML schema here. So we can define the person. The person consists of age, gender, and name. So age, gender, name, we can define the type. C data, gender is PC data, name is PC data. Okay, so we can define like structure or record in C or Pascal programming language. Document type definitions used to define new structure of data. Based on this DTD, we can instantiate actual record of a person, like the age 40, gender male, name is Peter Miller. Okay, so this is the XML schema. So protocol overview for NETCONF. So you can see NETCONF consists of 4 layers. Okay, so the bottom layer is layer 1 is secure transport. Layer 2 is messages. Layer 3 is operations. Layer 4 is content. Okay, so layer 1 is secure transport protocol like secure cell SSH or transport layer security TLS, the BIP over TLS, SOAP over HTTP over TLS. So those are secure transport protocols. On top of it, we can construct a messages layer like RPC, request reply, and on top of RPC, we can make netconf edit config over config. Okay, get config or something like that, and then over this operations layer, we can deliver compilation data. So this is called the contents layer. In the meanwhile, we also generate notification. Okay, so notification and data can deliver over notification like RPC. Also, this notification message can be delivered using secure transport layer. Okay, so NETCONF uses a simple RPC-based mechanism to facilitate communication between a client and a server. The client can be a script or application, typically running as part of a network manager. The server is typically a network device. Okay, so like a security network system, network security function like NFS. Okay, so I2NS application, we saw security function is a network security function. NSF we can regard as a network device. Okay, and security controller, we can give some command. It is we can say client. Okay, or I2NS user case deliver message, it is a client. Respond that I2NS users request, it is security controller treated as a server. Okay, so here we can see NETCONF RFC request and then reply here. So RFC request, remote procedure call, right? So we can eventually we want to deliver the get, okay, this message. Okay, so the parameter is user ID pred. Okay, and then RPC reply, we can get the user ID pred data here we can get, and then here the RPC message ID here, reply RPC message also the same message ID here. Also we have a namespace, XML namespace. Okay, so this is RPC namespace, this is external, this is a namespace. Okay, especially we are using the additional attribute called user ID. So in that case we can define using a Yang data model. We can define this one, and then we can get actual value of user ID using RPC reply. So here several NETCONF operations: get config, edit config, etc. Typically a get case is used to retrieve learning, configuration, and device state information. Similarly, get config case retrieve all or part of specified configuration data store. Okay, data store is this is a kind of a database specified Yang data model. Okay, and then edit case we can edit. Okay, specify the configuration. Copy case we can replace or create configuration data store. Delete case we can delete the configuration. Lock case we can lock the entire configuration data store. Unlock is we unlock previous locked operation. Cross session is request graceful termination of NETCONF session. On the other hand, the kill case session case force the termination of a NETCONF session. This figure shows NETCONF client and NETCONF server. So NETCONF protocol use on top of the RPC, right? So the NETCONF server connected the data store defined by Young data model. So NETCONF client sends RPC messages to the network device like NETCONF server. NETCONF server is running on top of a network device or network security system and interact with the data store. The data store contains configuration data and state data defined by Young data model, okay, method. Or so we can see, right? Data store is defined by Young data models. So let's take a look at NETCONF example here. To use a NETCONF, we need to define a Young data model. A validation case we can using validation tool like the PYOUNG, Young lint, and the web-based validator. You can click this one, and then in this example we'll use a simple Young module for network interface configuration. This example is executed with Ubuntu 20.04 LTS. So left hand side we have interface is a Young data model. Basically, the container interfaces includes multiple interfaces using list type. So the each interface consists of interface name and the state and the MAC address, IEEE L02 address, CSMA, CD, MAC, or L2.11, and the wireless LAN MAC address, and the IP is IP version 4 address, and the broadcast is IP version 4 broadcast address. Okay, so with the list type, we can make multiple interfaces within one interfaces container, and we can import the data types, okay, from ITF INET types, prefixes INET, and ITF Young types using prefix Young. Also, the whole namespace is specified tail.com namespace example interfaces, and this we can specify the IFS prefix case if we can using the defined sultan on the module. Okay, we can the types within that module we can reuse. Okay, like here INET case, the IP INET here, INET type like IP version for addresses, and also the MAC address case here, MAC case Young here. This module we can using Young MAC addresses for L2.3 or 11 MAC addresses. Okay, so this figure shows the previous this example. Can zoom in. Okay, this is a head part. Okay, and the import, and this is actual definition container interfaces. List interfaces means multiple interfaces can be contained this container interfaces, and each interface has the name. The key element is the name, and name is a string, and state is enumeration, just up and down, and the MAC address is this L2 IEEE L2 MAC addresses, CSMA CD or CSMA CA L2.11 G, B, and series, okay, and IP version 4 addresses, broadcast case IP version 4 addresses. So Ubuntu 20.04 with the Python 3 version, you can install pyang for yang validation, okay. So sudo apt-get, you can install Python 3, and then you can install the pyang, and the echo, you adding this pass for execution file, adding your bashrc file, and then you can update in your shell. And the copy yang module, the previous yang module, this one, put into a file. The name is interface yang using touch, okay. You can copy the yang previous yang module to this file, and then using a pyang to validate the data model here. If there is no message, means it returns nothing, it is fine. Also, you can show yang tree using -f option. -f3, you can execute pyang. You can show this kind of yang tree, okay, for interfaces. From now on, I will explain NETCONF server, ConfD. Okay, ConfD is an on-device management framework. Its main purpose is to enable device manufacturers to quickly provide end-user operators and high-level management systems with a set of rich, high-quality interfaces to manage a device. ConfD, this is open source, provides the tools to create the NETCONF server on your device. In this example, today's class will use ConfD to deliver firewall configuration using an NSF-facing interface yang module, okay? So with Ubuntu 20.04 LTS version, download the ConfD basic and install it according to this command, okay? So sudo apt install, and then unzip, sudo execute the Python 3, and then you can execute it, okay? And then Python, okay, install these tools. After that, source ConfD-rc resource file, configuration file, and then extract the interfaces tar.gz, okay, extract, and then start ConfD to activate the ConfD server using make clean all start. After that, we can check locally, okay. So open a new terminal and source ConfD, and then send a command get config XML to get the IP addresses configuration with NetConf, okay. So you can using this console command get config XML, you can get IP addresses, okay. The NetConf client case, from now on, we can see NetConf uses XML-based data encoding for the configuration data. It is needed for a NetConf client to send a configuration on XML file containing the configuration data to a network configuration NetConf server, okay. So you can send, okay, XML file including configuration data, and then you can configure NetConf server. NetConf is a session-based protocol, so a session needed to be initialized and operated, after that terminated. An example of a NetConf client is shown in the next slide, okay. So here, NetConf case, the first part is session initialization part. The second part is this is the actual operation part, okay? So actual get configure, okay? And the last part, this part is a termination part, okay? So also you can see each XML part here. The first part is session initialization. We have this sequence of character, cross, okay, square bracket, and this angle bracket, square angle, and then so this is indicate the end of the XML part, okay? So and then new actual operation NETCONF, and then this is termination part, okay? So this sequence of character is used to indicate the end of a message, okay? To send the compilation to NETCONF server, use the following command, okay? So source conf.drs, and then NETCONF client, okay? And then host, okay, ID is this IP address, and then we can get command the get configure XML, okay? Using this one, we can get the interfaces, okay? So this is NETCONF server address, okay? So we can get NETCONF server's IP addresses for, okay? We can get interface information. So let's take a look one by one. So first part is this is capability. This is initialization part. That is a part of XML file to initiate the handshake, okay? So the hello, this the method is used, okay? So the capability, this is exchanged, okay? Above example, the client start a NETCONF, okay, session with the hello message. The client tells the server about its capability, okay? The capability is NETCONF Based the version 1.0, okay? It shows that the supported capability is NETCONF Based, okay? And the URN, uniform resource name capabilities for NETCONF are shown this link. And after initialization, this is actual request operation, get config, okay? So our goal is we can get interface information, right? So this is XML namespace, okay? So we can get compilation using get config, okay? So this XML is used to only retrieve the learning data store for the interfaces, okay? So you can get the more operation result. You can using multiple request operation after this sequence of end of message characters can be used. After your request, this is termination XML part, okay? So you can close the session, okay? Message delivered, okay? So this session can be closed automatically if a session is abruptly disconnected without any proper cleanup. However, this might leave problem to the server and give some warning log, okay? The better way is to always close a session, no matter what it is. So you execute this NETCONF console command, okay, and then you can this, okay, machines, okay, interface information can be retrieved kind of okay, locally you can get, okay, or remote case you can using NETCONF client this host, okay, and the command get config XML, you can get remote NETCONF server IP interfaces can be retrieved, okay. So this is local IPAS, so your loopback interface and then other interfaces can, okay, displayed using this get config, okay. So next is RESTConf RFC 8040. This RFC you can get this link. So introduction to RESTConf. RESTConf is an HTTP-based protocol that provides a programmatic interface for accessing data defined in YANG. So using the data store, so you this one is okay, the access, okay, accessing, okay, defined NETCONF in RFC 8040. So NETCONF defines a configuration data store and a set of CRUD. So CRUD stands for create, read, update, delete operations, okay, to access these data stores defined by YANG data model. So RESTConf uses HTTP methods to provide CRUD operations on a data store containing YANG defined data. So the motivation of RESTConf, most of industry engineers, they are familiar with REST API. REST API, this is HTTP-based RESTful protocol using get host post method, right, to get or execute some operation or store some computation or form. So most software developers know REST API, but do not know NETCONF. So using RESTConf, this is similar to REST API, but it supports NETCONF. So without learning new protocol NETCONF, web developers or network developers, they can using YANG-based NETCONF concept using RESTConf. So RESTConf methods using HTTP methods, okay, similarly REST API. So here options head, get, post, put, this is REST APIs, okay. So using this one, we can execute the same NETCONF operations: get, configure, get, edit, copy, edit, something like that, okay. So options head, get, and the post, put, those are the basic method REST API. Similarly, RESTConf can using this kind of methods. So options to discover which methods are supported by the NETCONF server, and the header case to retrieve just the header field for debugging, okay, and then get case to get retrieve data and metadata or resource, okay. It is supported for all resource types, okay. And the post case, two kinds of thing: create a data store, a resource, or invoke an operation, okay. So the first one is create a resource mode, okay. This case a data store, data resource is created, okay. So create a top level resource. Secondly, invoke operation mode case, we can execute, okay, invoke an operation. On the other hand, the put case to create or replace the target data store, okay. And then note, so you can this one compares between the differences between the post and the put method, okay. So the both post and the put methods can be used to create the data resources. The difference is for post, the client does not provide the resource identifier for resource that will be created, okay. And the target resource for the post method for resource creation is the parent of the new resource. Finally, the target resource for put a method for resource creation is new resource. And the patch and the delete. Okay, patch is sent by the client to patch a target resource. Okay, this is used to replace or update a certain field in the resource. And the delete case is used to delete the target resource. So this table compares NETCONF and LastConf. Okay, so the basic concept is the same. They are providing CRUD, create, read, update, delete operation. So NETCONF, they are using get config or edit config. On the other hand, LastConf, they are using HTTP methods like get, post, put, patch, delete. Okay, so they are encoding NETCONF using XML. LastConf, they support the XML or JSON. So transmission channel, SSH, secure shell, transport layer used. On the other hand, LastConf, they are using HTTP or HTTPS. Okay, so complying with the RESTful style. Compilation page, usually a NETCONF case, 2-page compilation is used. However, LastConf case operation take effect immediately without the need to be submitted in 2 phases. Tool case Python, NCC, NC client, and LastConf case C URL. Okay. In conclusion, so NETCONF is a network management protocol defined by IETF to install, manipulate, and delete the configuration of network devices. Okay. On the other hand, LastConf is similar with NETCONF, but uses an HTTP method to manage network devices. LastConf data can be encoded with either JSON or XML, while NETCONF can be encoded with only XML. In this class, the usage of NETCONF and LastConf using a Yang data model is shown with the examples for I2 and SF. Okay, interface to network security functions. Thank you for your attention. If you have a question, please let me know. Thank you.